Hello everyone, I'm Nethil from Microsoft, and today I'm going to show you how easy it is to model a curved tunnel in Midas GTS. So as you can see on your screen, this is the tunnel that I'm going to model, and it's a curved tunnel having a vertical and a horizontal curve too. So I'll show you the top view. You can see that it has a horizontal curve, and I'm going to show you the side view, which will tell you that this tunnel also has a vertical curve. In the next 10 minutes, I'm going to show you how easy it is to model this kind of a tunnel in Midas GTS, and at the same time I'm going to create the construction stages for this tunnel. So this is outer ground that I have modeled, and I'm going to model different excavation stages for this tunnel. So let's start the modeling of a curved tunnel in Midas GTS. So first of all, I'll create a new file by going into the file new option, and I will select the model type as 3D. The first step is to create the cross section of the tunnel. For that, I'll go to curve option, and I will create an arc for creating the cross section of the tunnel, and I'm punching in the coordinates for creating the cross section in the form of an arc. So as you can see here, the tunnel cross section in the form of the arc has been created. Now I'm gonna complete the cross section by joining the two end nodes of the arc. So I'll go to create a line, and I will ask the program to snap between the two end nodes or points of the arc, and this is how I have completed the cross section of the tunnel. But as you can see here, it is composed of two different edges. I will ask the program to give me a one single wire out of these two edges. So I'll go to curve make wire. I will select the two individual edges that I have here. I will click on apply, and as you can see here, now we have a single wire depicting the whole cross section of the tunnel. Now I'll define a guide curve along the layout of the tunnel. For that, I'll go to create 3D arc, and I'm gonna define the 3D arc, which will have a horizontal and a vertical cross section. So I'm punching in the coordinates for the start location of the arc, the second location, and the third location. And this is how I have created the arc along the layout of the tunnel. This arc has a horizontal and a vertical curve. Now I'll ask the program to sweep the cross section of the tunnel along a specified guide curve that I have created so that I can obtain the tunnel solid. So I selected the wire, I will select the guide curve, and before I actually sweep it, I will see the preview, and this is how the tunnel solid will be created. I'll click on apply, and you can see that the tunnel solid has been created by the sweep function of Midas GTS. Now I would like to create the rock bolts on this tunnel. For that, I will hide the solid, and I'll create the rock bolts at the specified location. So I will create different lines which I will mesh later to create the rock bolts. So here I am creating several lines that I need for the rock bolts in the tunnel. Now let me zoom in at this location, and I will demonstrate to you a very special and unique feature of Midas GTS. You can see that at this point of time, the rock bolts are not intersecting the tunnel cross section. So I will use the extend 2D feature of Midas GTS, and it will extend the rock bolts to make them intersect the tunnel cross section. So this is how I am extending the rock bolts so that they intersect the tunnel cross section. Now I will transform or translate this rock bolts at the specified locations to create more rock bolts along the length of the tunnel. So I will select the rock bolts that I want to translate. I will select the guide curve, and I'll define the distance by which I want to translate them. And as you can see here, the rock bolts have been created. So very perfectly, Midas GTS has created the rock bolts at the specified location of the curved tunnel. Now let's model the outer ground solid so that we can create the excavation stages of this tunnel. For creating the outer ground solid, first I'll create a rectangle, and I will ask the program to extrude the rectangle to create a solid out of it. So this is how I created a rectangular face, and now I'll use the extrude feature of Midas GTS to create the ground solid. I will give it a name, let's say ground, and once I click on OK, you can see that the ground solid is complete. I will increase the transparency level so that you can see it easily how the ground and the tunnel look like. But at this point of time, the ground and the tunnel, they share a common volume, which is undesired, because if I mesh it, there will be a duplicate mesh at the location of the tunnel. So I'll use the Boolean operation, and I'll cut the tunnel solid from the ground solid. So I will select the tunnel solid. So as you can see here, you can select the tunnel solid, and you can cut the tunnel solid from the ground solid. Now I'll hide the ground solids, and I will divide the tunnel solid based on the excavation process. For that, first I'll create a surface, and in the form of a rectangle I'm gonna create a surface first, and then I'll divide the tunnel solid based on this surface at different location to model the excavation sequences. So I will use the sweep translate feature again, and I will sweep translate the surface that I have created along the guide curve, and this is how the transformation will take place. And once I click on OK, you can see that I have created the surfaces at various locations of the tunnel depending on the excavation process. Now I'll divide this solid, the tunnel solid, based on the surfaces that I have created. So I'll go to divide solid. I will select the tunnel to be divided. I will select the different tool surfaces in the form of the rectangle that we have here. So you can see that I'm selecting individual rectangles, and it's very simple to select anything in Midas GTS. You just have to go over it and tap on it to select it. I will also divide the neighboring ground surface, and once I click on OK, you will see that the different tunnel solid based on the excavation process will be modeled. I'll increase the transparency, and you can see that we have the model that I have here. So this is how I am dividing it, and let us now mesh the tunnel solid. For that, I'll go to mesh, auto mesh solid, and I'll define the element size, the attribute. I will select the whole tunnel, give it a name, let's say tunnel, and once I click on OK, you will see that the tunnel has been meshed. Now I'll mesh the ground solid, so I'll activate the ground solid, and I'll again go to auto mesh solid. I will select the solid to auto mesh. I will define the element size, the attribute. This is how the meshing will take place. I'll click on OK, and you will see that at the location of the tunnel the meshing will be finer, and at the location as we move out of the tunnel location, the meshing will be coarser. So this is how the meshing has been done by the program. Now let's model the construction stages. It's very simple and convenient to model the construction stages. First of all, I will rename all the tunnel mesh sets that I have obtained. So I'm gonna select all the tunnel mesh set here, and I'm gonna go to rename the mesh set. So I selected all the mesh sets that I have here, and I will rename them based on the coordinate system, the Y being the first item along which the rename will take place. The naming rule will be tunnel, and the suffix will be 1, 2, 3, 4, so on and so forth. And once I click on OK, I have renamed all the mesh sets that I have here. Now let me show you the different mesh sets for solid for the tunnel. So the first is the first one that will be excavated, the second is the second one that will be excavated, and so on and so forth. So now I'll model the construction stages. I'll go to model construction stage, stage definition wizard. I will put the ground solid and the tunnel solid in the first initial stage, because in the first stage everything will be intact, and from the second stage I'm gonna deactivate the different tunnel mesh set one by one. Okay, so I'm gonna show you the construction stages now. Let me zoom in at the location of the tunnel. You can see that in first stage no excavation has taken place, second stage first excavation, and you can see the different excavation stages in the tunnel. Let me deactivate the ground solid and let me show you the excavation process again. So I'll go to construction stage, simulate construction stages. So here you can see how the different excavation construction stages have been modeled. Now let us see how we can model shotcrete in Midas GTS. It's very simple. You can just, let me activate all the solids, the tunnel solid that we have. Just go to the extract element option in Midas GTS and select the faces from which you want to extract the mesh. Give it a name, let's say shotcrete, and here I am selecting the surfaces on which I want the element to be extracted, and you can see this is how you can simply select the surfaces to obtain the shotcrete. So once I click on OK, you will see that different individual mesh sets have been obtained, and let me hide all of them at once, and I'm gonna activate some of them to show you. So shotcrete, different shotcretes, you can see that there are 2D mesh set, and you can again define them in several construction stages as I used to define the excavation process. Similarly, you can play around with the rock ports and you can define the rock ports in different construction stages. So this completes the model for curved tunnel including the excavation stages on Midas GTS. Thanks a lot. Have a good day.